Here we go. We have a question: split array in three equal sum subarrays. So you have given an array and we need to determine if array can be split into three consecutive parts such that the sum of each part is equal. If possible, return any index pair ij in an array such that sum of ij is equal to sum of I plus 1 till j, which is equal to summation of j plus 1 to n minus 1. So we have to divide into three equal portions, and otherwise if this is not possible we need to return an array with -1 and -1 values. Note here is driver code will print true if array can be split into three equal sum subarrays, otherwise it will print false. So suppose we have this test case. In this test case, we can split this array into three equal portions. First portion is this, which is 0 to 1, and next portion is this 2 to 3, next portion is this. So we need to return an array of indices. Either we can return this means 0 and 1 as a value, or we can return 2 and 3, or we can return 4 and 4. In this case it is not possible, and in this case it is not possible. So let's build the approach. So I have taken the same test case. In this test case, the first portion is this, next portion is this, next portion is this. So what we need to do, we just need to return the indices of this index and this index. So we have an array. Actually we need to return in the list, but let's consider an array. So we need to return 0 and 1. This 0 will always be there, so we just need to find the ending of the first subarray, because starting will always start from 0. So let's try to understand whether we can split the array into three equal portions. So the array can be only and only can be splitted if the summation is divisible by 3. If the summation is divisible by 3, so let me tell you. Suppose we have this. So in this we cannot split the array into three equal portions, so we want to divide into three equal portions, but in this case we cannot do. So this summation have to be divisible by 3, otherwise we cannot perform this. But let's take another test case. So let me take 5, 0 and 1. The summation is 6. Here the summation is 4, then 8, then 12. So 12 modular 3 is 0, then 6 modular 3 is also 0. But this is divisible, but this is not divisible. So we also need to traverse and find the indices. If indices cannot be found, we need to return -1 and -1. So first iteration will be to count the summation, and the next iteration is to find the ending index. So we have some variables. So I have, let's say, first of all, let's say I have current value is 0, then frequency is 0, then the ending index, its initial value is -1. So let's iterate. First we have value 1, so we add a value to this current. Next we need to divide. The summation is 12. 12 by 3, 12 divided 3 will give me 4. So one subarray sum have to be 4. One subarray sum have to be 4. Actually every subarray sum have to be 4. Whenever we found our first subarray whose summation till the ending index is equal to our target, then we need to store this ending index. So till yet our target is 4. So is our current 4 yet? No. we need to add more values. Current is less than 4, so let's add 3. Now current is 4, so we have found one such subarray. So current current is equal to target, then we need to store we need to store this value. So the target will be the ending index will be 1, because till yet we have found one such subarray, and it's time to iterate, it's time to move forward. So we need to consider one more subarray, and frequency will be 1 because we have found one such subarray, and current will be 0 to find next subarray. Because this subarray is possible, but let's suppose the value here is 5 and the value here is 3. The summation is still 12, but now it is not divisible. We have 4, but now we cannot have 4, we have more values in a subarray. So that's why we have to check till the end. So the frequency is 1. Frequency tell us how many such subarrays whose summation is equal to target we have found till yet. So next value is 4. So we need to add the current value to this value. Now it is equal to 4, means we have found one more subarray. But our ending index is 1. We need to found just one subarray indices. So now ending index is currently pointing to somewhere, so we does not need to update the ending itself. So let's update. We have found one more subarray, current is 0. To found next subarray, current is 0, so we add 0. We need to check, is current less than? Yes, it is less than, so we just need to move forward. Next we have 4, it is equal to 3, it is equal to target, sorry. So we update frequency, we update current. Next we are out of bound, so we have found 3 subarrays and the ending index is 1, so we just need to return 0 till ending index, in this case 0 and 1. So let's iterate for this. We have current which is equal to 0. We have frequency which is equal to 0. Next we have ending is initially pointing to -1. First we have 5. Actually this summation is 6 and we need to found 2. Our target is 2. So we have 5. 5 is current, so we need to check, is current less than? If current is less than, we will move forward. If current is equal, so if current is equal, then this is the subarray, so we will increment our frequency because we have found one subarray, and current will become 0. If ending is -1, means this is the first subarray, so we need to store the ending index. Or I have talked about if current is less, if current is equal. In this case current is more, so we cannot make current is more, means the partition is not possible. Current is more than target, so we just need to return -1 and -1. So that's how this algorithm will work. So let's code this. First we have sum. So instead of for loop we can apply stream function, stream method in the array itself, and here we need to find the maximum. You can find max, min, and in this case we need to find the summation. So we got the summation. If summation is not divisible by 3, we just need to return -1 and -1. So in this case we need to return a list. So from array we need to convert to list with value -1 and -1. So it will just convert. We does not need to first implement and add one value every time. So next we have some variables n, current, frequency, and ending. We have a for loop. We add the current value. If current is equal to summation, if current is equal to target value, means this is the sub array that we want. So if ending is -1, we need to store the ending. Next we have found one sub array, and current will reset to found the next sub array. If current is more, means it is not possible to divide the array, then uh, outside this the array can be divisible, so we just need to return the indices from 0 to ending. So let's give it a try. Let's talk about time and space complexity. In this code we have this, it will take order of n, then it will take order of n, the time complexity is order of n, space complexity is constant. So we have met the expected time and space complexity. Code is given in the description box. Thank you all for watching.